All right, hello and welcome to our first lesson in Unit 2, Graphing Proportional Relationships. Today students will be able to graph proportional relationships. Students will be able to read unit rate answers from a graph, and this is important for many real life problems like finding the costs per lunch or the cost per lunches. All right, so today we're going to be looking at proportional relationships. These equations have the form y equals kx. That's called the constant of proportionality, and it basically means we have one number multiplied by x. One number multiplied by x. So we don't have any adding or subtracting from that number so far. So we have y equals 2x would be an example of a proportional graph. We have y equals 3/5 x would be an example of a proportional relationship. Y equals -1/10 x would still be a relationship that's called proportional because we're not adding or subtracting anything. So some non-examples, y equals 2x plus 1 would not be proportional because of this plus 1 part. Y equals 1/3 x minus 2 would not be proportional because of this minus 2 part. Y equals 5 plus 3x would not be considered proportional because we're adding 5 to something that had been multiplied by x. So those are not proportional. These are considered proportional. So let's look at 4 examples and see if we can figure this out. So number 1, y equals x plus 2.3. This would be no, not proportional because of the plus 2.3 part. Number 2, y equals 2.3x. This one would be a yes because we're not adding or subtracting anything. Number 3, y equals 2/3 x. This would be a yes because we're not adding or subtracting anything. And number 4, y equals 5x minus 7 would be a no because of that subtracting 7. So anytime we have an adding or subtracting to something that had been multiplied by x, then it's going to be a no. So proportional relationships are just one number multiplied by x, or in other words, something being multiplied by that x term with no adding or subtracting. So if you wanted to fill in no adding or subtracting, you could write that to the side. No adding or subtracting is the rule for proportional relationships. So we're going to be playing with some of those today, sort of graphing them, looking at graphs, and noticing some patterns with that today. You will notice that in this unit we have 2 variables, so it's not just x anymore. So before, where we would have had, let's write some examples up here at the top. Before, where we would have had an expression like 2x equals 6, and we would divide both sides by 2 to get x equals 3. In that case, in 2x equals 6, we only have one answer. X can only be 3. But in this unit, we're going to get equations like 2x equals y, where it depends what we plug in for x to give us a lot of different answers. So in this case, if we plug in 3, yes, we get 6, but if we plug in 2, we get 4. If we plug in 1, we get 2. So we have 2 variables this time. We have an x and a y, because we can change up whatever we plug in for x is going to give us a different answer for y. So that's where this is different from our last unit. So in order to keep track of all these different answers that we get, what we plug in, what we get, what we plug in, what we get, we keep track in a little table. And so if we look down here to number 5, we're going to write the equation y equals 3x. And we have to make a table to keep track of all of our answers. And then we're going to make a graph to keep track of where the answers would go from there. Notice the graph that we have here is just the positive quadrant. We're going to focus on just the positive numbers to start with, starting at 0. So if we plug in 0 for x, notice we always fill in what we plug in for x first. If we have 0 x's and our rule is y equals 3x, then that means we take out the x and we're going to replace it this time with 0. So to figure out y, we think y equals 3 times 0 this time. So if y is going to be 3 times 0, that means 0 times 3 is 0. So we get the point 0, 0. So we keep track of our points on the graph as well. Now let's try the next easy one, 1. So if x is 1, that means I'm using this rule, y equals 3 times x, to get y equals 3 times 1. Well, if y is 3 times 1, then y is 3. So we're going to go over 1 and up to 3. So this is the x-axis, this is the y-axis. And so we think, okay, well, when we plugged in 1, we got 3, so we would plot the point 1, 3. What about if we plug in 2? Y would equal 3 times 2 this time. 3 times 2 is 6, so we would go where x is 2, y is 6. And let's go with one more. That would give us y equals 3 times 3, or in other words, we have 3 copies of this, 3 copies of 3, and that would give us 9. So we would go x is 3, y is 9, and let's see, let's count from there. 5, 6, 7, 8, 9, and we went over 3. Okay, so we should be able to see that our dots, our points, our ordered pairs are all forming a straight line. And so these are called linear relationships. So it makes a line, so it's called linear. So I'm going to write the word linear down here, just because you're going to see that word show up a few times, and linear literally means it makes a line right there. All right, so in order to get some ordered pairs, we picked values for x. So let's write down what we did here so that you remember what to do. So pick numbers, or pick values for x, plug it in, and that will give you values for y. So plug in your values for x to get values for y. Okay, and we're going to practice this a few times. Now, if we see a graph already done, we can look at the unit rate by looking at whatever the y is per the x. So the unit rate, if we go back up here, the unit rate is also called, this constant of proportionality is also known as the unit rate. The unit rate. And so if we want to figure out what the unit rate is, we want to solve for the unit rate, then we would divide both sides by x. So over here, I'm going to write that down, y equals kx. So if I want to find the unit rate, we're going to refer to this as the unit rate in the next examples. So if I want to find the unit rate, I'm going to get that by itself, then I divide both sides by x. So that tells me y over x is going to equal the unit rate. You see, I already had that written down here, so I'm just going to erase that one and use this one. So the change in y over the change in x is going to equal our unit rate. So in this case, we don't have any labels for y or x because this was just a number example. But if we had a label on this, like dollars and hours, it would be dollars per hour. In this case, I'm going to look at the easiest example right here. The change in y here was 3. The change in x here was 1. So I'm going to say that this unit rate was 3 over 1 equals k. And we see that in our equation right here. 3 over 1 is the number that was in front of x, but it's because that's how y is changing per every x. All right, so let's look at some more examples of this so you can see what I mean by all of this. Let's go to the back of that first page and let's look at number 6 now. Number 6 has some labels on it that you need to fill in. So number 6, we're going to be talking about miles and hours. So we're going to use this expression. Instead of y and x, we're going to call it m and h, miles and hours. Go ahead and label your graph that way. If you need to pause, go ahead and pause. All right, so we're going to look at miles compared to hours. So we always plug in the x value first, and in this case, the x value is hours. So we refer to it as h, but you can think of it as on the x-axis. So if we plug in 0, we will get m equals 3/4 times 0. Okay, so if we have 3/4 times 0, we get 0. So that means we start at 0, 0. Now, as I go to plug in numbers for this one, I want to make it only have whole numbers. And so if I have one copy of 3/4, that means I just have 3/4. That's not a whole number. What if I had two copies of 3/4? Well, that would give me 6/4, still not a whole number. Let's add another copy. Because remember, that's what multiplying is. It's repeated addition. 6, let's see, that'd be 9/4. Nope, not yet. What about another copy? Let's see, 6, 9, 12/4. Okay, 12/4 would give me a whole number 3. So how many copies did I need of that in order to get to a whole number? I needed 4 copies. So if I use 4 copies of 3/4, I get m equals 3/4 times 4. That gives me 3. That gives me the whole number 3. So that means when I plugged in 4, I got 3. So I have a point right there. So that tells me if I use multiples of this bottom number, then I will end up getting whole number values. And that's really what we want. So the next one would be 8. And we can use our little pattern here. If I plug in 8, m equals 3/4 of 8, then these can cross reduce and I get 6. In other words, I can continue with this pattern. 8 is going to give me 6. 8 goes up to 6. 1, 2, 3, 4, 5, 6. And that means if I continue with this pattern here, 12 would give me 9. And we can check that by multiplying 3/4 times 12, cross-reducing, and getting 9. So we can show it that way. All right, so let's go over here to 12. And then go up 9, 6, 7, 8, 9. And again, we see this linear relationship occur. It has a straight line pattern. And so if I were to describe this unit rate is that K, is that number in front. I can say that's 3/4 dollars per hour is how I would describe that, because that's the Y over the X. Sorry, this one wasn't dollars. This one was miles per hour. So this would be 3/4 miles per hour. Or we could write that as 0.75. But let's keep it as 3/4 because that's how it was shown here. So the unit rate here would be 3/4 miles per hour. All right, let's try another one. This one has a decimal, 2.5, and we're looking at V compared to W. And we're not labeling what the V and the W are this time. We're just calling them V and W. And so we know whatever it is, it's going to be V per W. All right, and this one is listed as 2.5 W. So let's start by plugging in 0, the easiest one. And so that tells me that V would equal 2.5 times 0. And that's going to give me 0. So we start the graph at the point 0, 0. Now, if I were to use a 1 here, I would get 2.5. But we want this to just have whole number integers. So I'm going to skip the 1 because I know if I have 2.5 plus another 2.5, that's going to give me whole number 5.0. And so that means I used 2 copies of that. So 2.5 times 2 will give me 5. All right, so 2 is going to go up to whole number 5. So that tells me let's use multiples of 2. Let's use doubles every time. So 2.5 then times 4 would be the next one, and that would give me 10. So I'd go 4 up to 10. And let's use our next one to be 6, and that would bring me up to 15. And for these, I'm using the pattern, but we could also multiply it out and see what that would give us. All right, so that would give us, let's see, 6 and 15. So 6 is going to go up to 15. That's how I would plot it on the graph. That makes a linear relationship. And I know my constant of proportionality, my unit rate here is going to be 2.5, whatever V represents, per whatever W represents. So that's how I could read it on the graph as well. So I can see it's going up 5 over 2. So I could either read it as the unit rate being 2.5 V per W or 5 over 2 V per W. All right, remember that you do have an exit ticket for this. Complete the exit ticket and let me know if you have questions. Goodbye.